Good morning, everyone. Thank you for joining us today for the Introduction to Solar, Thermal, and Photovoltaics Systems webinar. My name is Beth, and I'll be co-hosting today's webinar, which means I'll be monitoring chat and conducting some polling at the end of the webinar. Today we'll be covering highlights from our half-day seminar, our half-day seminar, Solar, Thermal, and Photovoltaic Systems. We hope that after today you'll be able to understand some of the fundamentals of solar and apply them at your facility to help you save energy and money. We also want to thank our sponsors, the Energy Trust of Oregon and Northwest Energy Efficiency Alliance. Based on customer feedback, we know that, that customers appreciate the fact that we're aligned with these two organizations to help eliminate any confusion regarding energy efficiency and renewables. Before I introduce the speaker today, I'd like to show you some tools you'll be using during the webinar. To the right of your screen, you'll see several windows: the participants window, the chat window, and at the end of the seminar, you'll see the polling window. If you have any questions during the webinar, you can submit them to me through chat. So submit them to me, the host, through chat, and the instructor will answer them at the end of the webinar. Because this will be an informal session today, if you have any questions that you would like addressed immediately or you want to share an example, please feel free to use the raise your hand symbol, which you'll see you can do using the raise your hand icon at the bottom of the participants window. And at the top left corner of your screen here, I'm going to highlight some tools with a red line. Above the red line, underneath the Quick Start tab, you'll see some annotating tools, including an arrow, a marker, and a text tool. And the presenter will ask you to use these tools on specific slides during the webinar. So he'll remind you about those. And I'd like to introduce our speaker today, Bruce Barney. Bruce is with Portland General Electric. He's a professional engineer. He has been a solar PV homeowner since 2006, and he's an energy expert, solar energy expert here since 2001. He's a member of the American Solar Energy Society and a board member of Solar Oregon. So he is very well versed in the subject matter and should be able to answer any questions you have. So I'm going to hand the webinar over to Bruce.
Good morning, everyone. Welcome this morning. As Beth mentioned, this is an introduction to solar PV and thermal technology. So our goal is to give you kind of an overview of the basics. Let's see, we're going to talk about how good a resource it is, try and overcome some misconceptions about Oregon being a terrible place for solar energy. Talk about solar thermal systems where we can use the sun to make some heat, and then solar electric systems where we use it to make electricity. So without further ado, let's get into the system. To help us better understand who our audience is, I wonder if we could ask you to use those tools to just kind of let us know what your role is at your particular business or organization. This will allow us to hopefully tailor the presentation as we move forward. If you could just check off whatever seems closest to your role, that would be great. So here we are in Oregon. The rainy, cloudy weather has just started, and you may be thinking, well, how can solar work in Oregon? One of my goals here is to overcome that misconception that solar is not a good resource here in Oregon. The beauty in Oregon, as you may know, is that we have wonderful summers. And summers here are when we can really maximize the use of our solar resource. And even though we have 6 months of rainy, cloudy weather in the wintertime, we have lots of good weather in the summertime. That summertime is when the sun is high in the sky and we get lots of energy from it. So although the winter is terrible for solar, we aren't losing too much because the sun would have been low in the sky and not have too much energy for us anyway. So that works out real well. Solar in Oregon does work well. Okay, it looks like we've got some facilities and energy people here, and a few others as well. So we'll try and mention facility manager and energy manager kind of roles and what you might be interested in as we move forward. So one thing about solar is that it's a fantastic resource most anywhere you are where there are people. It makes sense to use solar energy. It's a great resource, and over time it's going to become more and more cost effective. You can see on this slide that we receive a tremendous amount of solar energy, somewhere around 275 million gigawatt years. So we could meet a very significant portion of our humans' load by just using a little bit of solar. The hard part is finding a way to convert that solar energy into something useful. That's what we're going to talk about today. Wanted to give you a little background on where the United States is and Oregon relative to the rest of the world. As typical, we're a little behind Europe. Germany is one of the leaders in Europe. You can see they have 3% of their energy needs coming from solar, 2.5% in Italy and Spain. We're down at less than 1%. You may have heard that California is a big user of solar energy. They are. However, in California, they still use a lot less than Germany on a percentage basis. And interestingly enough, California has a much better resource than Germany does in terms of how much solar energy is available. But the good news is, in the United States, we're still seeing a lot of growth in solar energy. The first thing we wanted to talk about today is solar thermal. As I mentioned, this is where we capture thermal energy or heat energy from the sun. We're going to talk about the technology used, the costs and the benefits, do a little bit of discussion about site analysis, what makes a good site, and then talk a little bit about incentives and how those are organized, how they work, and how big they are. One thing about solar thermal is that there's a lot of history with solar thermal. It's not a new technology, but there's a lot of misconceptions about its performance based on history. Back in the 70s, Jimmy Carter was president. He instituted a lot of incentives. A lot of people threw some solar thermal up on their roof, and a lot of those systems weren't very good, frankly. Modern systems are much different than those older systems. They use equipment that's specifically designed for solar thermal systems. They use high efficiency collectors that weren't available back in the 70s, modern controls. So the bottom line is modern systems last a long time and they don't need a lot of maintenance. Those are two big differences from what they used to have back in the 70s. So if you've heard about solar thermal being problematic, please try and put that behind you and look forward at modern systems which are quite efficient and quite long-lasting. So they have a very good payback if you have the right application. One of the reasons that solar thermal incentives may be less than solar electric is because the payback is so good. You don't need as much incentive because it makes a lot more sense to do solar thermal than solar electric. In the case of incentives, one of the drivers there, though, is to develop technology. So even though solar electric may not make sense on a payback basis by itself, the incentives are helping to develop the market. Okay, solar thermal systems are basically solar hot water collectors. Generally, any solar thermal system is going to use some form of water or water mixed with antifreeze. They're going to put the heat into the water and then make the water do work for the system. Solar water heaters are very efficient at taking energy from the sun and converting it into BTUs inside that water, and they work real well. Just to give you a sense of the savings that you can achieve, the savings you can achieve, a typical household in Oregon can save more than 50% of their water heating costs by implementing a solar hot water system. So solar thermal does work great. It works great for residential systems. And if you have the right application, it works great for industrial or commercial systems. The picture that you see here is of Lucky Labrador brew pubs in Portland. They instituted a solar thermal system to preheat their water for their brewery. It's working very well for them. As you can imagine, there's a lot of hot water needs when you make beer. They use this solar thermal to offset their need for gas to do hot water heating, and they're very, very happy with it. Wanted to ask a little bit about how interested you and your company is in solar thermal. So wanted to ask how important your facility's hot water energy costs are to your company. If you could let us know by checking off with a tool how important your hot water needs are to your bottom line, that would be great. One of the things about solar thermal is that it's very scalable. You can put a very small system up or do, as you saw in the last slide, put a very big system up. I'd encourage you, even if you have no real hot water needs, to look at solar thermal, even if you only use it to heat up water for your restrooms, for example. It can make a lot of sense and, again, cover 50% or more of the costs to heat water for your company. It looks like solar thermal is somewhat important to a lot of people. I don't see too many big users of hot water here in the audience. So let's move on. Wanted to give you a sense of relative performance and savings. You can see on the vertical axis here, we've got annual energy saved going up that axis, and we've got different locations on the horizontal axis. You can see that in Salem, the lowest level of savings is achieved, but it's still very significant. Even Reno and LA are only, what, maybe 25% more than you can save in Salem. So again, here in Oregon, even in the shady side of the mountains, you can achieve some pretty good savings. Wanted to talk about the technology used to collect solar energy via solar thermal systems. As I mentioned, generally we're always using water as a working fluid. If there's freeze potential, we probably will add antifreeze to the water. Systems are usually active, and by active I mean we're incorporating some pumps and automatic valves and controls. That would be versus passive, where you just use the differential in water density between hot water and cold water to move the fluid around. There are some systems that are totally passive, but generally speaking, we're going to be using systems that have active devices like pumps in it. Basically, all the collectors will expose the water to the sun, heat the water up, but they do that in different ways. This is a real typical collection scheme. I wanted to show you this because there are some common elements that are, as I say, real typical of solar thermal systems. The big one here to look at and talk about is the preheat tank. Basically, the way this works is you take cold water coming in to your facility. That generally is in the 40 to 50 degree range Fahrenheit, so it's very cold. As you heat it up and put it into your facility, we're generally in the 110, 130 degree range. So there's a very large delta in the temperature between what comes into the facility and what goes out of the hot water system. If we can take and preheat that cold water with sunshine, it can take a very large percentage of the need for heating up with electricity or gas and use the sun to do that. So that's the function of this preheat tank. The beauty of this system is that the preheated water tank, if there's no sun, all the water still goes into your regular water heater, and your regular water heater is sized to be able to handle cloudy days as well as sunny days. So it can still give you all the hot water you need, even on a cloudy day. On a sunny day, however, the preheat water tank is going to have all the heat you need. The water goes through the regular water tank, but it doesn't need to add any more heat in that regular water heater tank. So you use just solar energy to heat all your water. So this is a real typical scenario for solar thermal. It works great. It gives you the backup of your regular water heater and allows the sun to heat as much or as little is available. Now, in terms of thermal collectors, there are two main types. Flat plate collectors you see here in this picture, they basically have pipes in a black box. There's a plate of glass over the box to hold the heat in as it gets collected. The pipes have the water going through it, and the water is heated up as it goes through the hot pipes. This is a traditional system. In the old days, people used to make them themselves. Take a plywood box, put pipes in the back, paint it all black, put some glass on top, and there you have a flat plate collector. Nowadays, they're a little more high-tech than that. They work very well. They're relatively inexpensive. The efficiency, however, is not as good as the next type of collector I'm going to talk about, which is evacuated tubes. Now, these are similar to flat plate collectors, except there's no real box around the pipes. Instead of a box, each pipe has an individual outside enclosure that's clear glass. The sun comes in, hits that glass, goes through the glass, and absorbs on the pipes that are inside the glass tube. The beauty of these evacuated tube systems is that inside that clear glass pipe is a vacuum. So the sun's energy can go through the vacuum, warm the water in the pipe, but then the warmth from the pipe cannot go back through a vacuum, so it stays in the pipe. These evacuated tube collectors are very efficient in terms of converting the sun's energy to heat, but they're a little more expensive than flat plate. So, what type of sites work well for solar thermal? Things to think of as you look at your site are both the load side and the solar exposure side. On the load side, the bigger your hot water needs, the more cost-effective a solar thermal system will be. So you want to maximize your effectiveness if you have a big hot water need. Examples of this, of course, would be laundries, breweries, as you saw, hotels and motels with a big laundry system in them, industrial users of hot water like dairies, food processors. People like that have big hot water needs are a natural fit for solar thermal. One of the nice things I should mention about solar thermal is that it's easy to store the energy. So even if you're an industrial user who uses hot water 24 hours a day, you can collect the solar energy during the sunny day and store it for use in your second shift, third shift. Let's see, solar exposure. Where you put your panels should have a pretty good solar exposure, especially from the hours of, say, 9 a.m. to 3 p.m. That's where most of the energy is actually going to hit the panels. So if you have shading from, say, 6 a.m. to 9 a.m., that's not necessarily a terrible thing because there's not too much energy hitting those panels in those early morning hours. Same thing in the evening hours. One misconception that people have is that you must be a south-facing exposure. That's not exactly true. You can easily be 45 degrees either way of south and still make a pretty good system. The effectiveness of your system will be less than if you have a due south exposure, but only by several percentage points. So you can still get 95%, for example, of your incoming energy if you're 45 degrees off south. So don't be dissuaded if you can't get due south. If you can get close to south, you're going to be fine. Lastly, you need to think about space and weight constraints. These panels are typically pretty heavy because they've got water inside them. So if you're putting them on a roof, you have to make sure your roof has structural capacity to hold them up. Briefly, talking about costs and benefits, I've mentioned that you can easily save 50% of your heating load, heating energy by putting solar thermal in. I've talked about scaling up the systems from small systems to big systems. All those things make cost effectiveness pretty good. Let's see, for perspective, a typical household in Oregon will use 1 or 2 panels. That's all you need to meet the hot water needs of a typical house. Commercial applications can be scaled up from there. So if you think of a typical house, the raw cost of the system is going to be $5,000 to $8,000. Incentives will bring that out of pocket down pretty significantly. Okay. For incentives on the commercial side, the Energy Trust of Oregon is a great place to get incentives. If you're thinking about solar thermal, you're going to want to talk to the Energy Trust about their incentives. They have different ranges of incentives based upon what utility you're working with and what your existing fuel source is. It can be a little bit complex to figure out what your incentive is going to be. Large sizes may have to be custom tailored to develop an incentive by working closely with the Energy Trust, but typically the incentive from the Energy Trust is going to be 10 to 15%. In addition to that, you're eligible for a federal tax credit of 30%. That's 30% of the eligible costs, which basically means you have to subtract the Energy Trust incentive from the total costs to get your eligible costs. Another thing that you should talk to your accountant about is the MACRS, which is an abbreviation for Modified Accelerated Cost Recovery System. You're eligible to take depreciation and cost recovery on an accelerated basis with the tax system, and by doing that, it basically makes your system cost less. Your accountant can give you the details of that, but what I've heard is that basically that's another 10% of the cost that comes back to you as an incentive. There is special property tax treatment available as well, so you won't pay the significant property taxes that you otherwise would, at least for some portion of the time. So that's another incentive to be aware of. Now, let's move on to solar electric. We're going to talk again about the technology for PV or photovoltaic systems. Talk a little bit about what makes a good site. It's very similar to what we talked about before for solar thermal. We're going to go through some costs and benefits, and then again talk about incentives. Wanted to give you some vocabulary so that if you talk to contractors and such, you'll be aware of what they're talking about. This slide shows in red some of the common terms that you'll hear about. First off, everybody's familiar with what a solar panel looks like. In a solar system, the solar panels are put together. The next building block, the panels are put together in terms of a string. So multiple panels are wired into a string. Multiple strings are wired into an array through combiner boxes. So basically this has to do with how the wires are run, but each panel puts out a certain amount of power. You wire those panels up in series to make a string, and you wire strings up in parallel to make an array, and those string wires get connected in combiner boxes. So that's a different way of saying the same thing. Again, some of these will be terms that you'll hear, but for example, combiner box, you won't need to understand that, but you need to be able to understand what the contractor's talking about. The output of the strings and the output of the array go to an inverter. This is the device that is the heart of the system, the other heart, I should say, after the panels. The inverter converts the direct current from the panels and creates alternating current that's suitable to put into the grid. In terms of the panels, there are three main types: mono, polycrystalline types, and thin film types. Monocrystalline has the best efficiency right now in the high teens. So for example, of the 100% of the sunshine that hits one of these panels, you might get 18% of that energy converted into electricity. On polycrystalline, maybe 15% of that would get converted to electricity. Now, I should mention that it's easy to tell at a glance monocrystalline from polycrystalline. You can see this panel on the right looks like a solid black panel that's made up of square chunks of silicon. This is monocrystalline. It's very uniform in color. This over here is polycrystalline. You can see it looks like kind of an ice cube. You can see the threads and filaments and various crystal arrays there. So this is polycrystalline. You'll also notice that on monocrystalline there are little spots with no panel. This is because in monocrystalline they grow the crystal in cylinders and then slice it and dice it and create panels that have corners cut off. In the polycrystalline they actually use squares of material, so there are no openings between the little panels. Now on thin film, that's a very different process. It basically prints a panel using a printing process. They're very low efficiency, about half of what poly and monocrystalline are, but they have some other advantages. They're very lightweight and they're very inexpensive. So the bottom line is, to get a given amount of output, you may have twice as much thin film, but it'll cost about the same as polycrystalline or monocrystalline. When would you use thin film over one of the others? Well, your contractor can help you make those decisions, but some of the benefits of thin film are it's very lightweight. So if you have a lot of space, you're not constrained on space, you may say thin film is the best solution. It won't overload your roof, for example. If you're constrained on space, you only have a very small roof, you may want to go with monocrystalline to get the most output from that small space. I'll mention here that panels are rated in what we call STC, Standard Test Conditions. This is sort of like the EPA's gas mileage on cars. It's designed to give you a benchmark so you can compare panels from one manufacturer to another. STC is basically the full output of the panel. They actually put an artificial sun on the panel and measure the output. In Oregon, those panels will produce under that condition just at the very highest output of our day. So you might see the full output based on STC rating only for an hour at noontime in the summertime. So if you put up a 3 kilowatt system, you really shouldn't expect to see 3 kilowatts produced out of that system very often. Moving on to the inverters, as I mentioned, these are one of the hearts of the system. Without an inverter, you don't have much, unless you just want to charge some batteries or something. Usually people use one inverter per array, unless a really large array is used. I should mention they are very scalable. You can get inverters from just a few watts to many thousands of watts. The 1 megawatt size would typically be used by a utility or a very big system. Let's see, I should mention microinverters. This might be something you hear about from a contractor. Depending upon your site, a microinverter can be the way to go. Microinverters are where instead of one big inverter for a system, you attach an inverter to each individual panel. So a small inverter is wired to each of the panels. This can increase the efficiency of some systems based on your site characteristics. One of the big reasons you would do this is when you have some shading issues on your array. So for example, if you have telephone wires and electric wires that cast a shadow on your panels, as that shadow moves across your panels during the course of the day, that can impact your output pretty significantly, particularly if you have just one big inverter. If you use microinverters, the effect of that shadow will be a lot less. So microinverters is a term you might hear about. Wanted to give you a sense of PV growth. We're seeing continued growth in PV even with the reduction in incentives over time. The big driver for this, of course, is as incentives go down, we're also seeing the raw cost of systems go down. You've probably heard that PV panel costs have declined very significantly in the past 10 years. It's pretty dramatic how low the prices are right now. It used to be that you had to pay $8 a watt to get just the panel for a system. Nowadays, the installed cost of a system is in the $4 per watt range. So you can see by that that the costs are very much lower than they were just a few years ago. Oftentimes, people will say, well, how big a system do I need to produce how much power, or how big would that system be on my roof, or how much power can I get out of panels if I cover my roof? So I wanted to give you some photovoltaic rules of thumb that we use here in Oregon, west of the Cascades. First off, need to talk a little bit about how this is measured. Kilowatts and kilowatt hours are something that's very confusing to many people, particularly when you first start looking at doing a PV system. A kilowatt is an instantaneous output. So for example, at any given time, you could put a meter on a solar system and say, I'm producing this much power right now. If you produce that much power for an hour, you can say, okay, now I've produced that many kilowatt hours. So a kilowatt hour is kilowatts of production on an instantaneous basis times how long you did it. If you look at your electric bill, you'll see that what you get billed for is kilowatt hours. So this is the unit that actually has value to you. So you may be able to say, okay, I want to put a 1 kilowatt system. I want to put a 1 kilowatt array on my roof. But that won't tell you how much economic benefit you'll get. You have to then take that 1 kilowatt array and say, how much kilowatt hours will I produce every year? Then you can figure out how much that's worth to you. So here, west of the Cascades, 1 kilowatt of PV system will provide 1,000 kilowatt hours per year. And again, this is a very scalable system, so you can say, okay, if I put a 3 kilowatt system on my roof, I'll get 3,000 kilowatt hours per year. So this is a very good rule of thumb to remember. East of the Cascades, you'll get about 25% more. Now, going back to the value per year, let's just say you have 1,000 kilowatt hours per year. Here in our territory, rough numbers, each kilowatt hour is worth about 10 cents. So you'll make about $100 worth of power per year out of each kilowatt of array that you put on your roof. So that's how those numbers work. Now, that same kilowatt of solar panels on your roof will take up about 100 square feet on your roof. Now, this is for crystalline panels. So an area 10 foot by 10 foot will be 1 kilowatt worth of power. And again, using that same 1 kilowatt as a basis, the cost will be in the range of $3,500 to $5,000 for that 1 kilowatt. Again, it's very scalable, so 10 kilowatts would be $35,000 to $50,000. Now, these costs are raw costs. You have to apply the incentives to them to figure out what your out-of-pocket and what your long-term costs will be. Wanted to talk about another benefit of renewable energy and how that might impact your bottom line. This one, we wanted to ask you how involved your customers are with renewables, because that drives the value of having renewables on your roof in terms of a business side impact, because there's a PR benefit to having solar on your roof. So if you could just check off where you think you are on the spectrum in terms of what your customers' feeling about renewables is, that would help understand who your customers are. Now, the benefit, the PR benefit of having solar on your roof is kind of hard to determine, but we find that from an advertising perspective, or even just if your customers are conscious about renewables as they drive up to your building, if they can see the solar panels on your roof, that can give you a benefit. It's hard to tell how much that's worth, but I wanted to kind of highlight the fact that there is a PR benefit to you. So it looks like most of you say your customers are interested or may consider renewables. Here in Oregon, just throw out one thing about PGE's customers. We are number one in the nation for customers who pay us extra dollars to have green power come into their home or office. So in Oregon and PGE territory, we tend to have people who are very interested in being green. So again, don't discount the PR impact of having solar energy on your roof. Going on to PV costs and benefits. The costs do vary pretty significantly, as we talked about, $3.50 to $5 per watt. That's a pretty big range. The differences come in when you start looking at site factors, how you're going to mount the array to a roof or to the ground, how big a system you have. Of course, there's some scaling. Bigger systems cost less per watt than small systems. One of the reasons that happens is because permitting costs tend to be fixed. So if you apply permitting costs over a small system, your cost is bigger per watt than over a big system. Another aspect of cost is what kind of panel you use. As I mentioned, thin film has a big area. Multi-crystalline has a bigger area than monocrystalline. So depending upon the panel type, it can impact your cost. But again, that $3.50 to $5 per watt is probably a good range using costs in the market today. Now, site requirements for PV are, as I mentioned, very similar to solar thermal. A couple things to keep in mind. You don't need to have early morning sun necessarily or late afternoon sun if you have good sun in the middle of the day. You don't need to be exactly south. You can be near south. Keep in mind that these panels need structural support, so you'll be talking to your structural engineer probably about the roof and what it can support. Here in our territory, PGE territory, we find that a lot of buildings of recent construction were built very tightly relative to code requirements for loading. So you really need to talk to your structural engineer to see how much weight per square foot you can add to your roof and still have the code required minimums for additional weight for things like snow and rain. One thing that you may not have considered is that to get the incentives, you need to have a pretty good roof life remaining in your roof. The reason for that is the incentive dollars are coming from the public in general, so people who are managing the incentives want to maximize the use and the effectiveness of those dollars they spend. They don't want to incentivize a new solar system on a roof that's going to require that the solar system be removed to re-roof in the near future. The rationale for that is many customers, let's say 5 years down the road, the economy gets tighter, you don't have enough money to both re-roof your system and reinstall the panels. So you might elect to just re-roof the building. If that happens, then all of the incentive money that went to that solar system was wasted after that because your system no longer is functioning. So there is a requirement for incentives that your roof has lots of life left. To put that into perspective, I believe the incentive package now requires at least a 10-year life left on the roof. But that's something you need to check with your contractor on as you move forward with looking at solar. The contractor will have all the details about the incentives. You should also consider where wiring will run. If you're doing a PV system, you should have your array fairly close to your electrical connection. You don't want to be putting your PV system on one end of the roof and find out that you have to have a long run to any kind of connection for your wiring. That can get pretty expensive, so that's kind of duplicated with this entry nearby connections to your power system. Here's one for you. Make sure your interconnection is approved by the utility. You need to work with your utility. There's both an interconnection issue and a business arrangement issue with the utility. So you need to work with the utility on both of those aspects. I'd recommend you do that before you sign on the dotted line to at least talk about any problems that might occur. We've had here at PGE some customers move forward and the cart gets ahead of the horse and people end up in trouble because it costs more than they anticipated. Incentives. Incentives for PV are very similar to solar thermal. In Oregon, and if you are with Pacific Core or PGE as an electric utility, and a few people in Idaho Power, the Energy Trust will incentivize PV. The incentive varies a lot with size, with utility, so you need to talk to the Energy Trust, talk to your contractor about the details of those incentives, but there is an Energy Trust available for commercial PV. On the state side, you may have heard of the Business Energy Tax Credit. That's very hard to get nowadays, so there's a very slim chance you might be able to get a Betsy. Talk with your contractor about those details. Generally, the state incentives have gone away for commercial PV. So you need to rely on Energy Trust. You need to rely on federal incentives. Now, those two are available for commercial PV. There's a third option, and that's the feed-in tariff. If you choose to go with a feed-in tariff as an incentive, you're not eligible for the Energy Trust of Oregon incentive. So basically, you have two options for state incentives. You can go with the Energy Trust, or you can go with feed-in tariff. You have to make a choice of which way to go based on what makes the most sense for you and your system. Talk to your contractor. On the federal side, everybody's eligible for a tax credit of 30%. Again, it's for eligible costs. In other words, after Energy Trust incentives, you're also eligible for the MACRS or the Modified Accelerated Cost Recovery System. Again, that's worth about 10% of the cost. We wanted to ask how you felt about your company's leadership and what they might think of solar, either solar thermal or solar PV. One of the things I love to see on a roof is combined solar, where everybody has two systems on their roof. Because of the tremendous efficiency of solar thermal, we always recommend that people do solar thermal before they do solar PV. In other words, if you're going to spend money, solar thermal is the place to spend it first. But I should also mention that solar PV tends to be more popular. I think people like to see PV. It's a little easier to understand how it impacts their bottom line. Frankly, overall, if I was to characterize it, I'd say most people think solar PV is a little sexier to have on your roof. It makes a more interesting cocktail conversation. But anyway, solar thermal is the place I'd recommend people go first. Let's see. It looks like everybody here would like both a PV system and a solar thermal system. It's about split half and half. So that's great. I hope that as you move forward with looking at solar thermal and solar PV, that your company really thinks it's a good thing. Just wanted to talk briefly about some qualifications on the Energy Trust money. There are some gotchas out there on Energy Trust that I wanted to highlight. So these are the things that we've learned over time can be a problem. You must use an approved solar contractor if you want to get Energy Trust dollars. Now, the way you can find these contractors is to go to the Energy Trust website, energytrust.org. They have a great list of approved solar contractors. These are contractors that they have educated and they vet, if you will. So Energy Trust in this case is a little bit like the Better Business Bureau. They make sure that all their contractors are reputable. If there are problems with a contractor, they can actually come off of the approved list. So you can have some confidence that if you look at those contractors that are on the list, you'll get a good contractor. But the important thing is you have to use one of those approved contractors to do your installation if you want to be eligible for Energy Trust funds. Be aware that the Energy Trust, again, is spending public dollars, and they want to make sure they spend those dollars wisely. So you must have a good site. You can't put a solar system on a roof that never gets any sun because the Energy Trust doesn't want to spend money on a bad site. You also, as I mentioned, must have a good roof that has a lot of life left in it. You must, for solar PV, be in PGE or Pacific Core territory. So either you must either pay PGE or Pacific Core for your electric bill. And here's another one that's very important. Before you start on your project, before you start construction, you must have already gotten Energy Trust approval for the project. So you must pre-qualify the project. Don't let anybody start working on your roof until you're sure the Energy Trust has made a commitment to give your project an incentive. And again, for the Energy Trust, you have to get their dollars, you must not be a feed-in tariff customer. So this is an either-or situation. Either you get your Energy Trust money or you go with a feed-in tariff as an incentive. Wanted to give everyone some links for more information. The Home Power link is a great primer on solar. They have a spot on their website where, I forget the exact tab, it's called Learn More or something like that on their website, where you can click on that and they talk to you about the technology, the pieces, parts, how things go together, how they work, the different types of solar thermal systems, things like that. So Home Power is a great resource. It is tailored for the residential side, but of course the technology is pretty much the same. You can just scale it up if you're a commercial customer. EnergyTrust.org, I've mentioned the website to look at their incentives and to look at their costing and to look at the contractors list. It's a great overall site. You definitely should look at EnergyTrust.org if you're interested in going solar. Our website at portlandgeneral.com has a lot of information on it, and it's a great place to look where you can see how to do the interconnection for PV between your system and PGE. There are some forms that are available on that website. You can see the various ways you can do business with the utility if you're generating your own power. Okay, I wanted to kind of give you a plan for going forward. The next thing that I'd say to do is to look at your site and say, is it feasible to do solar at your site? Let's see. Wanted to talk about, basically you should look at your site, and look at shading and look at solar thermal loads or electrical connections. How close are you to those locations? Talk to an approved solar contractor. You would expect, these contractors are available and most of them are very anxious to talk to you. They'll give you a site assessment and give you a rough financial idea of what's involved. Go to energytrust.org to see those contractors, and then just move forward. It's quite easy. Contrary to, I think, most people's perception, you work with a contractor, they can give you all the forms, you sign on the dotted line, and then you start saving money. It's that easy. So thank you very much for participating in the webinar. I hope it's been helpful to you. Let's see, we'll turn it over to Beth to close down, and thank you again.
Thank you, Bruce. We want to remind everyone of our upcoming webinars that I have here on the screen. Actually, tomorrow we have, and the next day we have 2 seminars on LED lighting, also an electrical safety awareness seminar on October the 31st. But our upcoming webinars are compressed air, October 24th, and understanding LEDs on November the 8th. I'd like to draw everyone's attention to the polling window that should appear on the right side of your screen. We really appreciate your feedback and hope you take the time during the question and answer period to fill out that survey. Within a few days, we'll be sending you a follow-up email with a recording of the session and the PDF of the materials. And now I'd like to go directly to the question and answer section of the webinar and start off with a question we received about solar thermal. Bruce, what temperatures do you achieve in the preheat tank?
Good question. Let's see. One of the nice things I mentioned about that preheat tank is you can get energy into that preheat tank on a cloudy day, not much energy, or on a sunny day, you get a lot of energy. So let's say in the preheat tank on a cloudy day, the incoming water temperature might be 50 degrees. You might only see 65, 70 degrees coming out of that preheat tank on a cloudy day. On a very hot day, sunny day, you could easily achieve all of your heating needs. So you could easily see 135 degree water coming out of that preheat tank. One of the things that these systems need to be designed for is overheating protection, actually. So if for some reason you're not using your full hot water load, that hot water tank, the preheat tank, could overheat. So when you do system design, you want to make sure that you've protected against overheating. Basically what you do is you shut the solar thermal system off when that preheat tank gets hot enough to avoid overheating. So I'd say that temperature-wise, you can get to the full output of your regular water heater in that preheat tank on a sunny day if you're not using much energy.
Great, thanks, Bruce. Next question is from one of our participants here. Did I hear correctly that the federal tax incentives are applied after the other incentives have already been applied to the overall cost? So example would be the overall cost of the project minus the state and utility incentives, then you get a new cost, and that new cost is divided by the percentage of federal tax incentives.
Yes, fundamentally you're correct. The way the federal tax incentives are structured, the wording says that you have to take any applicable grants off of your eligible cost to determine the cost basis of the incentive. So the real discussion is, what is a grant? It's been determined in the courts, I believe, the tax courts, that the Energy Trust incentive is considered a grant. So to develop your eligible costs for the federal tax credit percentage, you need to reduce your cost by the amount of that Energy Trust money. If you have other grants that have been applied to your project, you have to take the value of all of those grants off of your cost before you can apply that tax credit percentage. So the real discussion is, what is a grant? You really should be working with an accountant or a financial professional to figure all that out for your particular application. But in general, the Energy Trust incentive is a grant. There are USDA grants that are available if you're in a farm kind of situation. So you need to look at what incentives you're getting and determine whether or not they're a grant. If they are a grant, you got to take them off of your cost before you calculate your federal tax credit.
Great, thanks, Bruce. I think we have time for a couple more questions. Here's one. What is the actual size of the converters? Square footage, height, width, et cetera, that type of thing, approximately.
You mean inverter? I think that's probably an inverter.
I think probably inverter, yes.
Okay, so for solar PV, photovoltaics, I'll give you a sense of the smallest size, which might be for a very small residential system. That inverter is usually designed to be mounted on a wall, and it might be 8.5 by 11 by 3 inches deep. So if you think of taking a couple of spiral notebooks or 3-ring notebooks, stacking a couple of them up and stapling those to the wall, that's the size of a small residential inverter. Let's say 250 kilowatt inverter, which would be pretty big, might be the size of a bookcase, a rather large bookcase. A 1 megawatt inverter, which would be more on the utility scale size, might be 4 feet deep, 5 feet wide, and 6 feet tall. So the space for these inverters is generally on the small side, I'd say, but as you get bigger, it's very significant, so you have to plan for some space for the inverter. Another thing I'll mention relative to inverters is that they do put out heat. These inverters are pretty efficient at converting the DC energy that's coming from the panels into AC, but they're not 100% efficient in that conversion. The losses in the conversion are given off as heat. So on most of these inverters, you'll see heat sinks. You know, it'll have fins made out of aluminum that air is going by these fins to cool the inverter off. Or on the bigger inverters, you may actually have some fans involved to blow the heat away from the inverter. So you don't want to put these inverters in a small closet, for example, because the closet would get too hot. If you're putting an inverter in, say, a residential size, it's okay to put it in a garage, but you don't want to put it in a closet. It's great if you can put it outside where ambient air will stay cool, but please put it in the shade. If it's a bigger industrial size, they're going to have forced air cooling. It works great in the shade, but be aware they put out some heat. You have to accommodate that in your location.
That's great, Bruce. I think we have time for one more question, and that is, and I think you may have already spoken to this a little bit, but can you tell us more about the panels? Are there panels that do both thermal and PV, or was that a combination system? And can you talk a little bit more about those?
Oh, interesting question. Let's see. There's been a lot of interest in trying to design a collector that will do both photovoltaic or generate electricity and solar thermal. I have not seen any company that's manufacturing such a product right now. It tends to be difficult to do, shall we say. But it's kind of on the mind of a lot of different people. They're all trying to find a good application, a good product that'll do both. But right now, I don't know of any. The hard part is, of course, it's hard to do multiple and do them well. So at the moment, if you want to do solar thermal and PV, you basically need to have two separate systems.
Great. That was the last question. So thank you, Bruce, and thank you all for joining us today. We'll stay online a little bit longer in case any of you have any additional questions. And looks like there's still some time to finish that poll if you haven't done so. And otherwise, thank you all very much, and we'll see you at another webinar.